Most people learn blockchain and still have no idea where it actually works. Blockchain isn't valuable because it's new. It's valuable only when it solves real business problems. In this lesson, we move beyond theory and hype and look at where blockchain is actually used in the real world. In the previous lesson, we explored different types of blockchains: public, private, consortium, and hybrid, and how each design fits different trust and governance models. Now, we apply those designs to real business use cases.
In this lesson, we'll look at the real use cases where blockchain creates value, and, just as importantly, where it doesn't. Payments, tokenization, supply chains, identity, DeFi, NFTs, DAOs. Not as buzzwords, but as systems.
Traditional payments move through multiple intermediaries: banks, clearinghouses, and settlement networks. Each step adds time, cost, and opacity. Blockchain replaces that entire chain with a direct settlement layer. Value moves peer-to-peer, verified by the network, and finalized globally in minutes. This isn't about replacing banks. It's about upgrading the rails beneath them. This is why blockchain payments matter most where legacy systems struggle the most: cross-border transfers, remittances, and financial inclusion. When speed and cost matter, architecture matters. Tokenization doesn't create new assets. It modernizes how assets are owned and transferred. By representing assets as digital tokens, ownership becomes programmable, divisible, and instantly transferable. This enables fractional ownership, faster settlement, and global access to previously illiquid assets. The real value of tokenization isn't speculation. It's upgrading ownership infrastructure that hasn't changed in decades.
Modern supply chains don't fail because of logistics. They fail because no one agrees on the data. Every supplier, manufacturer, and distributor keeps its own records. Reconciling those systems is slow, expensive, and error-prone. Blockchain replaces these disconnected systems with one shared, tamper-resistant ledger that records every event as it happens. No single company controls the truth. Everyone verifies the same history. That's why blockchain matters most in supply chains, where trust is low, coordination is complex, and accountability matters.
Digital identity today is powerful and broken at the same time. Blockchain enables self-sovereign identity, where individuals control their credentials. Instead of sharing raw personal data, users share cryptographic proofs that verify claims, like age, education, or access rights. This reduces fraud, improves privacy, and shifts control back to the user, without sacrificing verification.
DeFi asks a dangerous question. What happens when financial rules live in code, rather than in institutions? DeFi replaces traditional financial intermediaries with smart contracts. Instead of trusting institutions, users interact with transparent, automated code that consistently enforces rules. Lending, borrowing, trading, and settlement happen without manual intervention. DeFi shows what financial systems look like when software becomes the infrastructure: open, programmable, and globally accessible.
NFTs failed as a story, but not as a technology. In reality, NFTs are verifiable ownership records for unique digital or physical assets. They enable licensing, gaming assets, digital credentials, and intellectual property tracking. The core value of NFTs is simple: provable ownership without a central authority.
DAOs are organizations governed by smart contracts instead of executives. Rules are transparent, decisions are on-chain, and participation is open to stakeholders. Treasuries are managed programmatically, and voting is verifiable by anyone. DAOs aren't perfect, but they force us to rethink how coordination and ownership work in a digital world. DAOs present a new model that challenges traditional organizational structures.
If you want blockchain explained without hype, like a real system, like this video and subscribe. We focus on how blockchain actually works in production, not just how it sounds on Twitter.
So far, you've seen where blockchain is used and why it works. But none of this is powered by trust, hype, or assumptions. It's enforced by cryptography. In the next module, we go beneath the architecture and into the primitives that make blockchains secure by design. We'll break down hash functions, Merkle trees, public key cryptography, digital signatures, and secure key generation, not as math problems, but as system tools. This is where trust stops being a promise and becomes something the system can verify. That's Module 2. Let's continue.